Hello guys, let's talk this GFG POTD. Remove half nodes. You are given a binary tree and you need to remove all the half nodes which only have one side. Return the root node of the modified tree after removing all the half nodes. Note out the output will be judged by the in-order traversal identity inside the driver code. Okay guys, so let's discuss the question and let's discuss the logic. So suppose there is a tree here. What he is telling is you have to remove the half nodes. Half nodes means nodes which have one child, right? So this is a half node. Let me use black ink. Yeah, so this is a half node. This is a half node. This is not a half node. This is a half node, which have one child, right? So we have to write a code. We would remove these two nodes, and insert this to this one and this node to this one. I used all same values, so means there's no problem in it, right? If mm, just we have to remove the half nodes. It doesn't matter with the values, right? So we have to this should link to here and this should link to here. So we have to return this tree, right? So we'll remove these three nodes, these two nodes, and we should return this tree. So for this one, it's easy question, guys. Yeah, but you should know recursion properly to do this one. So if you don't know recursion, you should learn recursion perfectly for this one. I'll be using recursion technique for trees. This one, this question. So let's discuss, guys. See, now in basic and the note, what the note says is after deleting this queues as an in-order traversal means it produces an in-order traversal and checks if the in-order traversal of the both our tree and the correct answer are same or not, and it returns the uh, false. I mean false or true means the code is so uh, time complexity big often okay height of the binary. So for this one, what I will use is basically you should know. I think you know in-order traversal. If you don't know recursion, you should learn it, guys. Recursion is very important in trees here. So learn in order traversal. I think you should know it in order traversal. So just basic cases. So first, let me give you a code, normal dry code, and we'll figure out the logic behind it. So okay, so let a function here. Now, what this function does is it returns a node means if I give a node and I'll write a function on it. If I write function, can we say function and a node here? If I give this any node to it, it should return me the same node value with its half nodes removed, right? With half trees or half nodes, right? Half nodes removed. So this should be done. But if base case, if root is null, means if it is null, then there is no or nothing, right? So I'll return root basically. Okay, return root. Okay, the base case. If and I'll do a what do you say? I'll tell you the recursive one. Okay, so if this node, if it has two elements, left and right, or let's check. I don't know left value, left it is null or not, right is null or. Now what I'll do, just I'll find out, right? I'll find out the left node and right node. Uh, Now what I will do is let me say root of left, and root of right. I'll write the values afterwards, but root of left and root of right, right? So suppose this should means this root means this root node should be purified, right? It should not contain half nodes. If this node should not contain half nodes, this node and this node both should not contain half nodes, right? Means this node should not contain half nodes. Means suppose if this is a head node, this node should not contain any half nodes, and this node should not contain any half nodes. If it is a half node here, this should be removed and this should be placed here, right? Yes, right. So now what I will do is if root of left, if means I'll write root of left here. Now what I will write? Function of root of left, right? See, let me straight to the point. What does function do? I didn't write technical logic here, but just understand if this function returns as a node with no half nodes, it should return as a node with no half nodes. Root of left, what it will do means if this is possible, if this should not, if it doesn't contain any half nodes, then a left node and right node both should not contain any half nodes, right? And I should place this node here. So I'm doing root of left equal to function of root of left. Now means now this one what it will do? It should it should remove the half nodes, right? Means it removes this one and it becomes here, right? See, I'll tell you again. Now assume we are here. We are here. What I write root of left. So root of left is initially this node here. But is it actually means but is it half node? It is half node. Yes, right. So this should be removed. So what we'll write function of root of left means function of root of left means this node, right? Suppose this is x node. We wrote function of x and this is y node. We'll write function of y, right? Now, what does function y do? It denotes this means this will be head node here, and again it traverses, right? Now, this what will do? It will check if it's half node or not. If it's half node, then it should delete itself and it comes back, right? So that's what I'm doing. I'm inserting means basically what I'm doing. I'm doing root of left equal to function of root of left. What is function of root of left? It removes this node and places it one, right? This one. That's it, right? Same thing. If both root of left and both of right should not contain any half nodes. So root of right and function of root of right I'll write here. And this is a what do you call a root of right? Sorry, root of right. Okay. Now root of left and root of right over. Function of root of left what will do? It goes to root of left and function of root of right goes to root of right. First this will let me iterate here in order traversal. Basic in order traversal. So this like this one, right? So for in-order traversal, use black pen. So it goes to the left, right? It is not null. Checks the base case. If it's null, no, it's not null. Again, root of left it will go. This function call. Again, this function call. So the end will come here. Again, root of left equal to function root of left, right? Again, this will go here. Here base case is there. Means what we are doing, function of node, root of left we are finding, right? So this is storing it. Node root of left means it store means root of left equal to where what we can say we are root of left means it's return node, right? So this function returns a node. It returns what node? It should return a node which it doesn't contain any half nodes, right? So it goes to left, 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 left. Root of left, it goes to left, right. Again, left, left, right, like that. If root is equal to null here, it should return null, right? It should return means it returns null. Okay, it goes right means this call is over. If you don't know means if you don't know reaction, you cannot understand it actually. Learn recursion perfectly and come here. And for root of right, it goes to root of right. Again, it goes back right because root is null here, base case, right? I explained recursion already. You can check my videos. And this is the node, right? So root of left returns means what it will be root means let me tell you function of root here, right? Head, right? It calls again one. This means it function of root or right. It goes here. Root of left means this left should be this right. Function of root of left, right? So it calls function of root of left. So like that, it calls every time until this base case is met, right? So it goes here, it comes back. Again, root of right will go, and again it come back. Last final, this node will come. Last final, this node will be there. Now what I will write is if this is a leaf node. If it is a child, means it's a half child article. Say if root of left means if this node is a half child means half node means it contains only left node or right node means either left or right. If it contains like that, I'll attach it, right? Root of left, right? If this contains the only if case here, if it contains left node means only left node. Now what I will do is return root of left, right? Means what we are doing, we are replacing this node with this node, right? See here, suppose let me say here it is there. Left node is nothing, right node is there. What we are doing, we are returning this node, right? So it directly goes to here and attaches here. Means root of left equal to function of root of left. So this cuts out and this attaches directly here. How is it attaching? Means we are writing here, right? Root of left equal to function of root of left. Now what will function of root of left? It will return a node with no nothing, right? With what can we say? With no half nodes. So this call will go. But if both cases went off, then we'll check if root of left means if it is a half node or not, and we'll return it. So at last, final return node. If if it is not a half node, it returns node. Means, see, this has two childs, right? So this should obviously like this only. We cannot remove anything. So we'll return this node, obviously. We'll check here. Here, base case, we'll check if it is a half node or not. So that's it, guys. That's the logic. Let me code it out. If you don't know the recursion, please learn recursion. It helps us in many things. So I'll construct a function here, obviously. Um, Move star. Okay. Next, light node here. Node star root. Yeah. I think that's it enough. If root equal to null, return root, right? Obviously. Or return null, you can write. Now, root of if a root if means if node is purified, if node is row does not contain half nodes, root of left should not contain half nodes, and right also should not contain half nodes, right? So function of root of left, yeah, yeah, okay, and root of right. I told you, right, what function gives us? It gives us the node with no means no half nodes. So we'll attach directly means we'll directly attach root of left and root of right to this and this. We're directly you can see it. We are directly attaching it, right? So after this, and we'll check if it contains any, if this root contains any half nodes or not. And history. Uh, okay, can okay. I'll write not equal to what I'll write means this node is a half node, right? Root of left is there, but right is not there. So basically here means we can say this is there, left is there, let's say right is there, but left is not there. We'll attaching directly here, sir. We'll attach any nodes it contains here also. We'll attach directly here. So return root of right. Same thing. Copy it and I'll paste it here. Else if I write or anything you can write, anything you can use. Write if also no problem. Normally replace left and right and return left of, yeah. Otherwise means it's not a half node. I'm checking if it's half node or not. So yeah, or here else no need because means you can understand, right? If it returns, yeah. So yeah, I think it should work. Return function root. Sorry, root. Yeah, I hope it works fine. Yeah, let me submit it. Yeah. So that's it, guys. So we'll meet in the next video.